Hi there, I'm recording this tutorial to help you solve a linear transportation problem using MS Excel. I have this Arizona plumbing data here, which I'll copy and I have put it in Excel. It's exactly what you see on your slide. So what is given to me here is the unit transportation cost, the factory capacity, and the warehouse requirements for bathtubs. My Albuquerque, Boston, and Cleveland are demand locations, and Des Moines, Evansville, and Fort Lauderdale are supply locations. Sorry about this message. I would rename this table here and let's call it costs per unit. And I would copy this table, Control C and Control V, and call it volume. Now in the volumes table, I'll delete my unit cost that have been given to me, and I will shade that area because that's where my volumes would appear. That's my data that I'm looking for, my final solution here. Additionally, I will move my factory capacity by one column and my warehouse requirement by a row, right? And let's call this as factory supply, and let's call this warehouse demand, right? Let me just make the border here. And now let's put the formulas in here. So my factory supply is basically sum of what Des Moines can supply, right? So it's the sum of the cells in the first row. It's my row total. Similarly, I would do for the second and copy the formula for the third. For the demand, it's the sum of my columns, so sum of the first three cells in the first column. Copy the data for in the second and the third columns, and you have your formula. I will create another cell here, which is the last cell that I need, and call it total transportation cost, which would basically equal Cij times Xij, which means sum product of my unit costs, comma, my volume. And I'll leave that at 0 right now. Right? Let's shade this as well, because again, this is where my final solution, my Z value here would appear, right? Now at this point, let's go into data and open the solver. Set your objective as the total transportation cost, and in this case, you want to minimize it. How do you minimize? By changing your volume cells. To add constraints, click in the white area and say add. Now if you remember, the number of constraints in a transportation problem equal the number of nodes in the problem. I have 3 supply nodes, 3 supply nodes, and 3 demand nodes in the problem, which means I'll have 6 constraints in all. On the supply side, my first constraint would be my factory supply should be less than or equal to its capacity, which is 100. And second constraint, second supply should be less than or equals to its capacity. And the last one would be factory supply should be less than or equal to 300. Okay? And you should see your first 3 constraints appear. Now let's work with the last 3 remaining constraints. Say add. And now this is the demand side, and always remember that in business, our demand has to be met. Whatever the customer needs, we need to provide them, right? So my warehouse demand should equal whatever they need. Demand equals requirement. Demand equals requirement. Okay? Change your solving method to simplex LP and click solve. Solver has found a solution. All constraints and optimality conditions are satisfied. So that's good news for us. No need for any report. Just say keep solver solution and okay. And ta-da! You have your optimal solution here. What this means is you should send 100 bathtubs from D to A, 200 bathtubs from E to B, 100 from E to C, 200 from F to A, and 100 from Fort Lauderdale to Cleveland. When you do so, it will cost you $3,900, and this is the minimum amount that you would incur in making this transportation. I hope, class, that this tutorial would help you. Good luck. If you have any questions, definitely let me know. And again, good luck. Bye-bye.